Hi Calculus 1 students. We are in section 2.3, limit laws, and we're going to do here a limit that is conceptually challenging the first time you see it. And I should say right away that the most important part of this video is the beginning, is when I discuss about what's going to happen. The algebraic steps, like as soon as you know what's happening, like it's very easy. So, okay, the first thing you do whenever you compute a limit is to directly substitute in it. In other words, you replace t with -4 and see what comes up. So -4 minus 12, -16. 16 minus 16, 0. Plus 8 over, so here we have 16 minus 16 again, so 0. Okay, something weird is happening. The first thing I would like you to remember is that whenever you have a number over 0, what comes up is that this is a vertical asymptote. And the limit could either go to infinity, go to negative infinity, or fail to exist. So let's just recap that by writing, okay? So number, so actually I will write it like this. Non-zero over 0, okay, means that you have a vertical asymptote. Okay? And if you have a vertical asymptote, it means that a limit could be infinity, negative infinity, or DNE. Does not exist. So why could it fail to exist? Remember that this is a two-sided limit. So it could happen that from below, when we approach t from values below -4, it could go, for example, to infinity. And if we are approaching -4 from above, from numbers above -4, it could go to negative infinity. And since the behavior is not the same, then in this case, we cannot even say that the limit goes to infinity or negative infinity. The best we can say is that it doesn't exist. Okay, now this is true for this part, but it's also true for that part as well. Okay, so I will say this here. So the same goes for this. So as a result, we end up kind of combining, adding two asymptotes. And here's what could happen. Okay, so we are combining two vertical asymptotes. And here are the possibilities. Okay, so first off, the limit could fail to exist. That is like the most common possibility. It could fail to exist. And we cannot say anything else. Another possibility, so let's actually, I will not even say this, maybe a bullet point. Okay, yeah, a bullet point. Another possibility is, let's say that this limit is infinity and this limit is infinity as well. In other words, the two terms are both blowing up, okay? So this is a scenario in which we have infinity plus infinity, and the result will also be infinity. So if the two terms are blowing up, the sum of them is obviously also blowing up. The same goes if these two terms are sinking down, if they are decreasing without bound. So if the first one is approaching negative infinity and the second one is approaching negative infinity, then the result will approach negative infinity. The tricky part, and this is also what could happen. So let's say, for example, the first is going to infinity and the second is going to negative infinity. then in this case, we don't know, okay? So we don't know, at least at first glance, okay? So it could be anything from these three possibilities. So it could be infinity, negative infinity. It could fail to exist, but it could also be or even a number. Okay? So all in all, this is what we call an indeterminate form. Okay? So, and yeah, I'll just take a last caller just to show you that I'm talking only of this member. So this is an indeterminate form. Okay. Now what I want you to notice is that just writing this, we don't know in which of these scenarios we are. To figure it out, we would need to take the limit from below and the limit from above. First of all, to see if we are in the same scenario regardless of the side we're approaching -4. But even like as we determine the sign of each of these terms, we could see like how they combine. However, okay, here's the practical idea. So doing this is certainly possible, but it's not necessarily a good idea. It would be quite time consuming. Practically speaking, what is much better is actually to add these two fractions together to get a single fraction. Because if we get a single fraction, we get only one of these, okay? And if we get only one of these, it's much easier to determine what's going on. Okay, so now I'm going to erase everything and tell you that practically speaking, we just add these two fractions and see what comes up. So whenever you are in this scenario, whenever you get two asymptotes that might combine in some funky way, just put it into a single fraction and see what comes up. Okay, so add fractions and see what comes up. Okay, so now we are solving the limit. So this limit right here, okay, is going to be equal to, we want to put these under the same denominator. And the first step by doing this is to actually factor the denominator to see if they might have something in common. So, okay. So the numerator, nothing changes. I'm just going to factor the denominator. The first one is a difference of squares, t minus 4, t plus 4. And the second one, it's just, that's it. Like it's, we factor something in common. Okay. Now, this is by chance, of course. Like it might not always happen. But notice that we have a factor in common. So whenever you get this, take advantage of it. This means that the common denominator is not going to contain t plus 4 squared, just t plus 4. So what I will do is I will factor it out of the entire expression. I will put it in front of the bracket. Let's put it this way. And then I'm going to leave some space in order to actually take the common denominator. So here I have 8 over t. Okay, so here what we have done so far is we factored the common factor. Everything else is unchanged. Now here goes the next step. I'll choose a different color, let's say red. So we put under common denominator. So this one is missing t, so we multiply and divide by t. And this one is missing t minus 4, so we multiply and divide by t minus 4. Okay. Okay, so first of all, it's easy to see the denominator. Let's actually write the denominator out. And I will keep the color code for the t plus 4 just for you to see that we still have to multiply these two factors, but we also have to multiply the common denominator by this. So here I don't need brackets for that little t. And for the numerator, we distribute. So remember that when you draw an horizontal line like this, there's implicit brackets in here. So and what we want to do is just let's distribute right away. Actually, we will have t squared minus 12t, and here plus 8t minus 8 times 4, 32. Okay. Now, as you can see, it's very appealing to just simplify before doing anything else. So we have the limit as t is approaching negative 4. I'm not doing anything else than just combining these two things. So t squared, here we have minus negative 12 plus 8. So minus 4t minus 32 divided by, that's it, t plus 4, t minus 4 times t. Okay. Now we're doing this again. We're doing the direct substitution because we achieved our goal. We wanted to play with only one fraction. So now we're going to easily know what's going on. We won't need to think about, oh, how do these two fractions combine? Okay, we don't have to think about this anymore. So as we plug in, we know for sure that the bottom is going to be 0. And the top, let's have a look. 16 plus 16 minus 32. So it comes up to be 0 as well. So it turns out that we are not guaranteed anymore to even have an asymptote. It might actually approach a finite value. So when we have 0 over 0, I also remind you that our goal is now to cancel a common factor that approach 0. So don't do any more algebra than necessary there. Okay, the bottom, we like it as is. Don't go expanding, right? Remember that your goal is to cancel a factor that's approaching 0, and we already have it at the bottom. We already have this t plus 4 that we are aiming to cancel. So that's why you don't want to do anything with this. With the top, so we're going to factor it. It's obviously a trinomial, so we know that we can we have a good chance to factor this out. So and as I can see, the two numbers will be negative 8 and 4. So this will factor out to t minus 8, t plus 4. And there we go. We have the redundant factor, t plus 4. So we cancel it. So I'll just write the limit before direct substitution because I don't like displaying, like doing too much steps on the board, like in our head. So we cancel the redundant factor, and now that we have achieved this, we should expect to not have 0 over 0 anymore. So now we should know what this is. Now, negative 4 minus 8 is negative 12. And then we have negative 4 times here we will have negative 8. So obviously the last step is the simplification. We know that the result will be negative, so don't play with the sign anymore, just figure out what the numbers are. And 12 over 4 is 3, so the result is negative 3 over 8. There you are. I hope that this helped. So see you in the next topic. Cheers.